Okay, welcome to the 1.2 example 1. So we're actually going to start to do some of these transformations, and really it's going to focus on just reflections to begin with. So in both of these cases, we are going to be comparing y equals f of x, and on the left here, I'm going to look at y equals a negative times f of x's, and that does mean that a is negative 1, which means we are going to reflect over the x-axis. And a lot of students do struggle with the idea that, a is applied to the outside of the function, y does it affect, and it doesn't affect the x values, but we put x-axis there. And again, that drawing I think is so useful that by reflecting over the x-axis, we are vertically moving these points. All right, and that's part of how these graphs are related, is that y equals negative f of x is y equals f of x reflected across the x-axis. Now I'm going to do that one in red, just so we can talk about both at the same time. And what that's going to look like is any point that has a y value of 0 is going to be invariant. And that invariant really just means that the point doesn't vary, it doesn't change. The other coordinates, I'm simply going to take their value, their coordinate, and multiply the y by -1. So point A here, instead of, and I'll write it down here, that the point A is at -4 comma -3. When I do the reflection, I'm going to call that A prime, it's going to be at -4 comma +3. So it's just going to reflect, and I'll draw a dotted line here, across the x-axis, which means that B will be located right here. This 0 comma -1 will turn to 0 comma +1. D at 3 comma 4 will turn into 3 comma -4. And finally E, which is at 5 comma -4, will turn into 5 comma +4. And then I can connect those dots in the order that they should be, and I get that to my graph. Now I'll label that as A prime, B prime, C prime, D prime, and E prime. And that's just so that we can talk about these related to each other. Now, I think it is important to make kind of a real world maybe connection here, that if we pictured the x-axis as a mirror, then any points on that mirror haven't changed, but everything else has been flipped from one side of the mirror to the other. Okay, I'm going to clean up that middle section, and I'm going to do the second part as well, which is y equals f of -x. And there's a really key difference between these, that if I compare y equals f of x to y equals f of -x, then my b parameter is -1, which indicates that we reflect over the y-axis. And again, there's a disconnect there that we see why we think vertical, but if I picture that y-axis as my mirror line, then as I reflect these points across, that is going to be a horizontal motion. And that makes sense because B is applied directly onto the X. Now I'll draw that underneath again, that a point here is changing there. I want to draw the mapping for this one, that X comma Y on f of X would turn into -x comma Y on f of -x. So D right here, which is at 3 comma 4, I'll put that D is at 3 comma 4, that would turn into D prime at -3 comma 4. I'll put D prime up there. Any point on the mirror line or the reflection line, which is this point right here, not labeled with a number, but they're labeled with a letter, but that's okay. That's going to be invariant because it's on the line itself and therefore not changing. C, however, is going to get transformed to here. I'll do E as well. E is at 5 comma -4. It is going to turn into -5 comma -4. That's my E prime right there. These other points, B goes from -2 comma -3 to 2 comma -3. That's B prime. And then A switches from -4 comma -3 to 4 comma -3. And then my graph gets a little bit ugly here. You might want to plot additional points here. This point doesn't have a letter associated with it, but it will turn into -4 comma 0. And then it can help a little bit, I think, to draw that reflected function. Now, similar to the other one, we should see that that black line is a mirror image of the original function. And then how these graphs compare to each other is that y equals f of -x is y equals f of x reflected across the y-axis.